All right, so we are going to be talking about kidney embryology. And kidney embryology is super important because, as it implies, it is setting up the kidneys. It's the embryology of the kidneys, which sets up the urogenital system, which allows us to filter our blood, allows us to regulate our electrolytes within our body, get rid of waste products. So a super important system, kind of complicated system, but super important. So let's get to it. Let's define some important terms first. So first thing is we want to identify that this is all happening at week 4. So this all starts at week 4 and then continues from there on. Let's also talk about the fact that there are kind of 3, we'll call them primitive kidneys. And what do I mean by that? So in the development of the kidneys, which happens in a cranial to caudal fashion, so that means if we're looking at the abdomen here, that's the belly button, these are the legs, let's give them shorts. This cranial to caudal means that it's happening from this direction to this direction. Cranial head to caudal tail. Okay. Let's get rid of all that. So it is happening in a cranial to caudal fashion, and at the top, in the cranial most aspect, we have first the pronephros. And then after the pronephros comes the mesonephros. And then after the mesonephros comes the metanephros. So what does all this mean? Great question. Basically, quick way to think about it is that the pronephros degenerates. What's its function? It doesn't function. It has no function. It's temporary. But what it does do is it sets up a blueprint. And it allows for the rest of the kidney to develop. So we will kind of get rid of this here to remember that the pronephros degenerates. Then we have the mesonephros. And the mesonephros, in large part, is going to degenerate, but it is functional for a temporary bit of time. So the mesonephros is, probably shouldn't have erased all that. All right, so the we'll just write in nephros because that's bothering me now that I didn't do that. The mesonephros is temporary, but it is functioning. And what do I mean by functioning? Well, it works as a temporary excretory unit. So it can temporarily filter the blood within the developing fetus. And then most of this does degenerate. In males, some of it sticks around. Some of the caudal-most parts of the mesonephros stick around, and they will turn into the Wolffian duct, which gives rise to the genital system. Okay, so, but we'll say, and in females it pretty much entirely goes away. Some of it can stick around, but for the most part it goes away. Then we have the development of the metanephros, and that's the most caudal part. And the metanephros, something that is important to remember about the metanephros is that it forms the kidney proper. So what we have inside of our bodies right now is metanephros. Metanephros is the kidney. Okay, great. So how does all of this get underway? So we talked about at week 4, we first develop the pronephros. So if you remember, I drew out a trilaminar disc over here, but let's take a look at it from a bird's eye view. So if this is our bird's eye view, this would be our notochord, these would be our somites on either side. Then we get our intermediate mesoderm, and I'm going to highlight this here because this is really important for this. And this is happening on both sides, intermediate mesoderm. And then you have our lateral plate mesoderm. Now, why is this intermediate mesoderm so important? Well, the intermediate mesoderm is super important because that is what is developing into the pronephros, into the metanephros, and intermediately to the mesonephros. So just remember, the intermediate mesoderm is what ultimately forms the kidneys. Now, this is kind of a slice through this, like this way, right here, if we were to look at it like that. This is what we're dealing with over here. This would be our somite, also known as paraxial mesoderm. This would be our intermediate mesoderm, which again is what is forming into the kidney proper. And then over here, our lateral plate mesoderm, which we're not going to concern ourselves with right now. So how does all this get started at week 4? So at week 4, we'll change the color up here again, the somite communicates with the intermediate mesoderm, and it says, all right, we're going to form some kidneys here. I need you to express PAX2 and LIM1. And what do these do? So these are transcription factors. We'll move these over here. And PAX2 is going to be an epithelialization factor. It's like a condensation factor. It condenses the epithelium. So I like to remember that because it packs everything in. It like packs the epithelium. So PAX2 is for epithelialization, which comes into play later with actually forming the nephrons. So no PAX2, no nephrons. Then we have LIM1. And what does LIM1 do? LIM1 kind of makes the nephric duct, which if we're looking at, let's just say that this is our bladder down here. This is the pronephros up here. This is, I'll put it in a different color, the mesonephros over here. And then we get kind of this metanephric mesenchyme formation over here, which we'll talk in a little bit more detail about. LIM1 sets up this part. And ultimately, this part, which is the ureteric bud, and we'll talk a little bit more about that as well, and how that ultimately branches out into these primitive kidneys. But you could kind of remember this in two ways. You could either think of this as, put this in red, as a 1, like the number 1. It's kind of a cheap trick. Or you could think of it as a limb, right? It's a limb. So this is the limb. It's like the bladder's limb. Limb 1 sets up the nephric cord. Okay. So what is happening now? So I said before, the pronephros largely disappears. By the end of week 4, it's gone. And sometime in the middle of week 4, you start getting development of the mesonephros. So just for clarification's sake and terminology's sake, we're going to call this the mesonephric duct and this the mesonephric mesenchyme. There's a couple different terms that are used for these. This is also the nephric duct, and then this is the nephrogenic cord. So this side is cord, this side is duct. If you're reading from left to right, C comes before D. So cord, duct. Great. So what is, we said that this has the mesonephros has some temporary functionality. And how does that temporary functionality come about? So if we were to zoom in on this over here, we would see that we have our duct, and then we have our, I know this doesn't stick with my CD mnemonic because we're on the opposite side now, but this is our cord on this side, this is our duct on this side, so mesenchyme over here. What's going to happen is this is going to start to elongate, form little caps over there, and as that's happening, this is happening to all of them, it forms these S-shaped tubules that start advancing towards the duct. And once this part over here becomes curvy enough, it connects into the ductal system. So I just kind of moved everything over here. 1 second. We'll bring this over here. And while that was happening, the arterial system is developing and is advancing a tuft of capillaries in the direction of this little capsule that we formed. And just like in the functioning adult kidney, this is our temporary functioning unit where blood is able to be filtered into here, then enters in, should have done that in a different color too, enters into here, and then down, and is able to be excreted. So it's a temporary excretory unit that is forming within the mesonephros. Now remember, that is not happening in the pronephros. And to a large degree, a much larger degree, that's happening extensively in the metanephros. So just to kind of rewind for a split second, all of this has to be localized to somewhere, right? So this is all happening kind of in the pelvic region. And what is causing all of this development to happen in the pelvic region? It's a good question. So we've learned about homeobox genes. And HOX11, homeobox gene 11, is what is going to largely localize the mesonephros. So the pronephros tubules are degenerating, they're connecting to the nephric duct, but they're not doing anything. The mesonephros is developing caudally, and the mesonephros is connecting to the mesonephric duct. So the metanephric mesenchyme, or the cord, is connecting to the mesonephric duct, or the nephric duct. Again, both derived from intermediate mesoderm. And all of these things are being positioned by HOX11, FOXC1, and FOXC2. So I like to say HOX and FOX put the position on lock. There's a little lock, right? HOX and FOX put the positions on lock. And while this is happening, from the mesonephros, we're getting this little outpouching called the genital ridge, and that's later going to develop into the genital system. But we're not going to concern ourselves too much with that right now. So we talked about the development of these tubules over here. Now let's take a look at what's happening in this mesonephric duct. So within the mesonephric duct, if we look at, let's just say we have all of these things connecting, and we have more of them, right? And these are our temporary excretory units. We have a little outpouching that happens right around here, and this is happening around week 5. This little outpouching is called the ureteric bud, and that's advancing towards our metanephric mesenchyme. And I didn't make this look like a kidney accidentally, because the metanephric mesenchyme is what becomes the kidney proper. So I'm going to create a new page here. So if we look at this again, the ureteric bud and the metanephric mesenchyme have a large series of interactions with each other. So what are those interactions? Okay, this is a little complicated. So we're going to make this, it's doable, but it's complicated. We're going to make this into a little schematic here. So I'm going to call this the ureteric bud, and this over here the metanephric mesenchyme. So as this ureteric bud is extending outwards and continuing to extend outwards and continuing to extend outwards, it contacts the metanephric mesenchyme. And in response to that, the metanephric mesenchyme releases something called WT1. WT1 goes back to the metanephric mesenchyme and says, okay, we've got an incoming ureteric bud, we've got some work to do. So it ramps itself up by expressing two other factors. It says, all right, let's make GDNF and HGF. These are two different growth factors. Now the ureteric bud conveniently, put these in orange also, has two receptors on it right here. One is called RET and one is called MET. And oh, how convenient, those receptors receive GDNF and HGF. Specifically, GDNF goes to RET and HGF goes to MET. So what happens when that's going on? Well, there's a bunch of different things that happen. And we'll come back to that when we talk a little bit more about branching. But for the time being, in response to this reception, there's like a little signal that's sent, and the ureteric bud says, oh, okay, we need to release FGF and BMP7. Wait, what? What does that mean? Okay, so first let's draw this out. So let me draw it right over here. So in response to this, it's releasing FGF2 and BMP7. So what does FGF2 and BMP7 do? So that will go to work on the metanephric mesenchyme. And that's going to say to the metanephric mesenchyme, it's like, these are like encouraging signals. It's like, okay, keep producing WT1, right? Don't undergo apoptosis, so no apoptosis, because we want to continue proliferation. So no apoptosis, continue proliferation, and continue expressing WT1, because WT1 is the thing that got all of this started to begin with, right? The HGF, the GDNF, so on, and then these series of plays. So BMP7 and FGF2 are like encouragement factors. So the metanephric mesenchyme cap, and let's define that. That's like this area that's forming right here. That's like a little cap. That is going to ultimately release some factors of its own in order to encourage branching and so on. So now, before we move on with this, let's talk a little bit about branching. So what's happening? So sticking with our schematic, here is our duct, here is our ureteric bud, and here is the metanephric mesenchyme. Remember, ureteric bud, metanephric mesenchyme. And something else that GDNF does is GDNF and RET, once they're met, once they complex, they will say, okay, stretch further. They'll tell the ureteric bud to stretch. And I remember that as GDNF and RET. What they'll do is they will stretch, right? So they stretch the ureteric bud. And then as that's happening, we're getting release of a factor called BMP4. This is different than BMP7, which is like the encouragement factor. BMP4, kind of, I like to think of it as, it's the bumper factor, the bump 4 factor. What it will do is it will bump the middle here, like indent it a little bit, and then GDNF stretches it. And then this will then come back over here. I lost my 4. And it'll bump this one. So it like puts a little indent in there. And then GDNF and RET, they'll cause that. So you can see after this continuous interplay happens, you kind of get this like fractillion pattern. And this happens continuously until you have 1 to 3 million tubules. Sorry, not tubules. Collecting ducts. And remember that these 1 to 3 million all derived from this ureteric bud, which was that little like diverticulum right there the metanephric diverticulum that encroached upon this metanephric mesenchyme right over here. And then this, if we take this right here and move it here, what is happening is this just extended outwards and kept moving like this, and that's how you form all those collecting systems. But that doesn't explain how we get our tubules. Now remember, we talked about our tubules forming before, and that is because we have, at the end of each of these, we have a little metanephric mesenchyme cap. And it makes sense because it's inserting into the metanephric mesenchyme. So this is like the little cap that's formed on here. So the millions of branches of the collecting system, what they will do is from over here, they're going to release a factor called Wnt9b and Wnt6. And what Wnt9b and Wnt6 do is they communicate to the metanephric mesenchyme cap, and they cause it to release Pax2 and Wnt4. I know there's like a ton of different things here. Whoops, sorry. So what Pax2 does, again, that's for epithelialization and the formation of those tubules. And then Wnt4 is going to allow for the upregulation of E-cadherin. It's going to allow for the upregulation of lamin. It's going to allow for the upregulation of syndecan. And it's also going to lay down type 4 collagen. So all of this, which is mediated by Wnt4, so these 4 things that are mediated by Wnt4 are going to create the glomerular basement membrane, that type 4 collagen. Remember, if you have a problem with your type 4 collagen, that's Alport's. It's kind of a digression from what we're actually talking about. But type 4 collagen is in your basement membrane. It's going to allow for like E-cadherin, so the adherence factors, and it's really setting up this whole kidney system. Now, there's a lot that's going on there, but what is really important to know is that the kidney is located in the pelvis and now needs to move up. So we have this kidney that's forming, and as it's forming, it's moving up. Sorry, I got a little distracted there. I had no clue what I was talking about for like 30 seconds. Okay, so I don't know why I said what is really important to know. All of this is really important to know. But if we go back to our person, right, we'll give him shorts, and there's his belly button. The kidneys are like right here at this point, and they need to move upwards. Our bladder is over here, and as the kidneys move upwards, so we'll put the new kidneys up here, they stretch that what was once the ureteric bud, they stretch it out and they form the ureters. Something weird happened. They form the ureters. And then the bladder is positioned by homeobox 13A. And it's like, stay put right there, don't move up with the kidneys. And then as the kidneys move up, they meet up with their suprarenal glands, which are already up there. And then they continue functioning, these little excretory units within there, which are nephrons now. They continue functioning, they continue developing, but the number of them is actually set. So all of the urine that they produce gets drained down here, and the umbilical cord maintains a connection through the allantois. And that's how the developing fetus is able to filter blood. So that's like a whirlwind tour of all this different types of development. So thank you.